Good day, viewers at home. You are welcome to our Abona mathematical class. Today we will be discussing sub-factorial. Before we discuss sub-factorial, we have to know what factorial is all about briefly. What are factorial? Factorial simply means reduction or decrease of an item from its original states to what? To unity. What is unity? 1. And factorial is denoted as this. In English language, we call it exclamation mark. In English language, exclamation mark, which is meant for what? Anxious moment or eagerness or anxiety. That is where exclamation mark came in what? In English language. Now in mathematics, this is the definition and this is the symbol of that. And I type of a great French mathematician, Christian Cran, a medical doctor, mathematician, was the one that designed this symbol into mathematics. And the meaning is reduction or decrease of an item from its original position or state to unity. Example, illustration. 5 factorial. 5 times 4 times 3 times 2 times 1, which is 120 from the definition. Reduction or decrease of an item, this is the item 5, from its original state, which is 5, to 1. Number 2 now. 3 times 2 times 1. That is 6. First example. Second example. Third example, 4 factorial. 4 times 3 times 2 times 1. This is how to solve it according to the definition of factorial. But there are some special cases. There are some special numbers that are special. Which is 0 factorial is 1. No reduction here. 1 factorial is 1. Why did I call them special cases? Note, anywhere you see 0 factorial or 1 factorial in mathematics, the value is 1. They are the same thing. Their value are what? The same. I call this axiomatic property. Axiomatic properties. Why? Or I call them special cases or exemption. Why? What are axiomatic properties? Axioms are facts that have no proof. The difference between theorem and axiom, they are quite different. What is an axiom? An axiom are facts that have no proof, while theorems are facts that have proof. You can see all this, they are theorem. You can see this, they are axiom, because they have no proof. Anyway, you see 0 factorial, the answer is 1. 1 factorial, the answer is 1. Pause. Now, the multiplication of 5 factorial is 120. 3 factorial is 6, and this one is 24. 4 factorial. From this basis, we are going to trash what we call sub-factorial. Sub-factorial, as I've said, factorial is denoted as this, which is n factorial. This is factorial. Why this sub-factorial will be sub-factorial n? This is it. Our factorial will come before what? Before the variable, which is sub-factorial n. This is what we call sub-factorial. Sub what? Factorial. Another name for sub-factorial, I can call it left factorial. Or I call it the arrangement. The what? Arrangement. That is another name for sub-factorial. Why? Factorial is what? Arrangement. Opposite of factorial is sub-factorial. And opposite of sub-factorial is factorial. I clean the board. Here, wait, I'm speaking. We solve the question of the day. Sub-factorial 3, sub-factorial 4, and sub-factorial 5. As I've said before, sub-factorial is denoted as this. And I want to solve. How do we solve? Or we call it the arrangement. The what? Arrangement. Why factorial is arrangement? For example, I have 1, 2, 3. This is 3 factorial. Or I can say, or 3 factorial is 3 times 2 times 1. I can de-arrange this. This is orderly what? Arrange. How will I de-arrange this? Because sub-factorial means de-arrangement. Now we saw, hey God, de-arrange this. I will de-arrange this when I'm de-arranging. The numbering must not be in the same position. They must not take the same position. Now, the first set. 1, 3, 2. This is the first outcome. 3, 2, 1. None of these numbers take their position from here. Another one. 1. Another one. 2. 1 and 3. None of them take the same arrangement. That means sub-factorial 3, it is 2. That means I can de-arrange sub-factorial 3 in 2 ways. In 2 what? Ways. Now, we have a proper formula to solve. I just want to show you what de-arrangement is all about, which is sub-factorial. Another name for sub-factorial is called de-arrangement. Now, let's solve. There are some formula we're going to use. There are 3 formula I'm going to use. 3. Case 1. This is the formula for sub-factorial. Sub-factorial is not common in textbook. N factorial is n factorial summation n. K equal to 0 minus 1 raised to power k over k. This is the first factorial. This is the first formula to solve. Manually, we have solved it. De-arrange to solve with formula to confirm this answer. Sub-factorial 3 equals to, I will turn it to normal factorial, 3 factorial. Summation this n is 3, while k is what? 0. Minus 1 raised to power k over k factorial. Now, I solve. The value of k is 0, 1, 2, and 3. I will stop because total number of items is 3. I will start from 0 to 1. I solve. Sub-factorial 3 is equal to 3 factorial bracket, I begin to substitute where they belong. Minus 1 raised to power 0 over 1 factorial. Plus the next one. Minus 1 raised to power 1 over 1 factorial. Plus the next one. Minus 1 raised to power 2 factorial. Plus minus 1 raised to power 3 factorial. And done. All these entries have entered this formula. I solve for them. Sub-factorial 3 equals to 3 factorial brackets. These are power 0, 1, 2, and 3. Minus 1 raised to power 0 is 1. Why? Any number apart from 0 raised to power 0 is 1. Example. 3 raised to power 0, 1. 6 raised to power 0, 1. 8 raised to power 0, 1. S raised to power 0, 1. But that's an exception. 0 raised to power 0 is not equal to 1. This is undefined. This one is undefined. This one is 1. This one is 1. And this one is also 1. This one is also 1. How? Any number apart from 0 raised to power 0, the answer is 1. Any letter raised to power 0 is 1. Now, this is 1 over 1 factorial, as I've explained earlier. 1 plus, when you have an even power, the answer remains negative. Minus 1 raised to power 1 is minus 1 over 1. 1 factorial is 1. Plus minus 1 times minus 1. 1 over 2 factorial is 2. Plus minus 1, this is 3. Minus 1 times minus 1 times minus 1. Minus 1 times minus 1 times minus 1. Minus 1 times minus 1, 1. Times minus 1, the answer is minus 1. I have minus 1 over 6. How is this 6? 3 factorial is 3 times 2 times 1. What's the answer? 6. From there, I solve for them. We have sub-factorial 3 is equal to 3 factorial bracket 1 over 1, 1. Plus and minus, minus 1 over 1 is gone. Plus 1 over 2. Plus and minus, minus 1 over 6. These are fractions. This 2 is gone. How come? 1 over 1 is 1. 1 over 1 is 1. 1 minus 1, 0. Now the rest. 3 factorial equals to 3 factorial bracket. I'll find the LCM here. 6. 2 in 6, 3 times 1, 3 plus 6 in 6.
Ready.
Now, as I was saying, I will finish up in the other side. Let's go. We have sub-factorial 3 equals to 3 factorial brackets. We have 2 minus 3 minus 1 is 2 over 6. Finally, answer has come answer. 3 sub-factorial 3 equals to 3 factorial is 6. That is this. Bracket 2 over 6. 6 cancel 6. The remaining answer, sub-factorial 3 is 2. This is QED. Quite easily done. Quite demonstrandum. It has been done based on the first method we use. Thank you very much. Viewers all over the world, you can see what I have done on sub-factorial. This sub-factorial is not really common in textbook like that. What we know is factorial. This has not been taught like that everywhere in schools. But I've dismantled this 3 factorial, the arrangement of it, first method, and the second method of solving it with that formula. You will go and solve this and this as your assignment. That is case 1. Now, I'm going to use another formula again to solve this superfactorial. I clean the board. Case 1 has been done. I want to show us another method, which is case 2 and case 3 of solving subfactorial. Subfactorial equals to n over e, which is the first case. The second method, subfactorial n equals to n factorial over e. This is the second method. Subfactorial n equals to n factorial over e plus 0.61 using the formula, and we are able to get an answer which was 2, the arrangement under subfactorial. Now, case 2, we use case 2 and case 3 to solve further as a shortcut to the formula that I've applied before. Now, here is E. I call this E Banker's constant. Banker's what? Constant. Or I can call it Euler constant. According to scientist Leonard Euler. Leonard Euler, a Swiss mathematician from Switzerland, was a great scientist that designed E into mathematics as a constant. And the value of this is 2.7182818281828 recurring decimal, continuous like that. Now, I want to experiment case 2 and case 3. We apply this case 2 when our n is even number. When our case 2 when our n is odd number. And we apply case 3 when our n is even number. That is what we do as a shortcut to case 1, the formula I've applied before. Now, to solve this now, subfactorial 3, I will apply this formula because 3 is an odd number. Viewers all over the world, to solve this and this as assignment, which I will give to you, you put your answer on my comment section. Subfactorial 4, because 4 is an even number, I will apply this formula. And subfactorial 5, because 5 is an odd number, I will apply this one as a shortcut to case 1, the formula we have applied before. And move to the other side. Now is equal to n factorial over e. This is the formula, which is 3 factorial over 2.71828. Subfactorial 3 is equal to 3 times 2 times 1. That is 3 factorial, 2.71828. From there, pause. At this juncture, we press calculator to get the final result because of this constant value. First and foremost, our threshold is 6 over 2.71828. Subfactorial 3 is equal to 6 divided by 2.71828. Answer 2.2072 7, 8, 1, 3, 2. Finally, sub-factorial 3 equals to 2 approximately. That shows the answer for the first method I used and the second method are the same. This is how to solve sub-factorial. Anytime, any day you come across it. Viewers all over the world, thank you for coming around my Facebook page, watching my mathematical teleclass on sub-factorial. I have done sub-factorial 3 using first method and the second method and show you people how to use second, third, and first. Go to my Facebook page, like my page, share my page to people all over the world. Attempt my assignments, trash out this, put in the comment section for me to see your answer. Bye.